Welcome back to Seek and Destroy. Number 1, anyway. So I assume it's gonna be I need to find the nearest thing that I want to shred. Yes, I know what you're thinking. It's true. Every piece of data is a precious miracle. Workers each have a line of precious miracles above you. Yes, take a moment to appreciate them. They're also green and uniquely numbered. Each of you must find the littlest data cube in your line. Aw, isn't that cute? But the problem with data is that small numbers just take up just as much space as big numbers. And storage space isn't cheap, you know. You can see where we're going with this. So let's just take that littlest number and shred it. Okay. Well, what I can do is just have people walk up in a straight line until they, I guess if they reach a wall, then they could just walk down and then shred it, which is probably the easiest, stupidest solution I can do, and it's exactly what I'm going to do. So, if my item is not equal to a data cube, okay, the first thing we're going to do is we're going to step up twice, and then we'll pick up the item. So we've stepped up twice, we then pick up one above us. So, yeah, this is interesting. I mean, there's something that I do at the start of a lot of my puzzles, which is I establish a precondition. So usually my precondition is get the workers to hold an item. Once that's true, then it's really easy to set up a loop because I don't need to loop back to like... I just know that if I loop back to this point, then I know it must be the case that my workers are holding an item. So I establish this invariant throughout the entire loop by doing that. So that makes it really, really easy to reason about these puzzles. That's something I learned in my very first programming class. So it's a very common and very, very, never mind. It's a very, very common and easy thing to do to make your code a lot easier to understand. So anyway, step up twice, pick up that cube, and if we'll just basically just keep taking steps up in a loop. And if my item is greater than the ground, then we'll pick up, or what we'll do is we'll drop to our right. Oh, we can't do that exactly. So what we'll do is we'll take a step to the right. Yeah, a step to the left works just as well. Drop the item. I wonder if I can just give to the left. But for now, we'll just take a step to the left, drop, and then take a step to the right to get back in line. And if there's nothing to compare against, I assume that we'd be comparing against null, which I assume will be 0, and that could potentially be very interesting. I'll see what happens in this case, my item, when we compare it against just the ground. So what we could do is, and we're standing on a data cube, just to make sure that we don't compare against the ground unnecessarily. And if to the top is a wall, then we're gonna jump out of this loop. And we're gonna walk the other direction, which is... Oh, we don't even need that. We can just use nearest. So nearest shredder, and then we're just gonna give to the nearest shredder. This ought to work. Let's see what happens. You think in recursion, so the first thing you try to find is the base. That's exactly what I'm doing as well. I'm just setting up my base cases, like, effectively pick up the first item in the list, assume that it's the smallest one, and if it's not the smallest one, then we do this sort of logic. But interestingly enough, this person did not pick up the data cube because I forgot a certain step, which was we step back in and then we pick up our data cube again. We pick up the newfound smallest data cube. But yeah, so the easiest way to find the smallest item, or the most correct way to find the smallest item in a list of items, is you always assume that the first item is the smallest one you've seen, and then you go through the rest. And that's exactly what I'm doing here, and that's a popular job interview kind of gotcha for, like, effectively filtering out people on phone screens. So, don't say you didn't learn something. And I think that that ought to take us through this puzzle here. They picked up 4, they picked up 14, they shredded 31, they shredded 12. Perfect! I don't think I did either of the optional size, but I think I must have done well on the speed. Ah, I'm so close on the speed. I guess the dropping commands probably were what killed me there. I wonder if instead of these 3 commands, I can do nearest data cube at mem2 and just pick up mem2. So this will run faster because I'm only running 1 command in a given cycle, so this should mean... Oh, the other thing is I have people going up to the top wall, which is not actually necessary. Yeah, I have everyone bouncing off the top of the arena, which is probably what's cost me those last couple of seconds there more than anything else. Oh, well. Your all-time fastest solution averaged 23 seconds. So I beat my all-time. I wonder, what's the trick for making sure that I don't have to bounce off this top wall here? If there was furthest, that would be hilarious. But I only have nearest. So I wonder if it would be possible to set... it'd be really funny if I could set that tile as the... So this just sets it to 1. It'd be interesting if I could set a counter. So if I could set it to mem1. If I could do addition by, like, setting a counter, then I could just check, like, if I've checked 6 things. Oh, but some of them have different numbers of things anyway, so that wouldn't really work. I wonder if instead of doing this drop, step, drop thing, I can do give to the left. Yeah, I can't do give tos on things that aren't shredders. Oh, interestingly enough, I don't need to shred only the smallest data cube. I can shred every single cube. So... I can complete the speed challenge, the shortest code challenge really, really easily here. Watch this. So, mem2 is nearest data cube, and we'll just jump, and we'll pick up mem2, and we'll give to mem1, and I've now completed this in five steps. Ah, all your workers have died? Why didn't that work? Oh, I guess I guess they do have some sort of check to make sure that you actually shred the smallest one. I thought for a second that I had found a loophole, but that's fine. Technically, by doing that, I would have shredded the smallest data cube in every column, so I don't know why they're not letting me get away with that. They specified no statement that I need to only shred the smallest data cube. Yes, did you notice? Whenever we delete the smallest number, there's a new smallest number remaining. If we delete that number, well, you see the problem here. Clearly we need to shred all the data cubes, but not in any random order like we used to. Each of you must shred all data cubes in each of your columns in order from smallest first to biggest last. Copy and paste your solution from the previous room as a starting point. This will take no time, basically, because all I'm going to do is just put this thing effectively into a loop. Ah, crap. Ah, craps. Ah, crap and a half. Oh. Oh. Well, I guess we're going back to the Seek and Destroy 2 challenge. Okay. So... Yeah, we get it. Okay, so we'll do nearest data cube. I hope that... Alright. So what we'll do is we'll have a loop to start with where we step up, and if we're standing on a data cube, then we pick it up, and we'll do a jump statement to get out of the stepping up loop. Okay, otherwise we will just keep stepping up until we're standing on a data cube. Now, so this is just going to be called get cube. This one's going to be called get lil boy. And then we'll just follow the same sort of thing that we were doing before. Alright, so what we do is if... Okay, so what we do is just keep walking up, bounce off the wall, just like we were doing beforehand. If above us is a wall, then we're going to jump out of this thing. Oh, no. So first we're going to set our shredder to be the mem1. So now we'll just give to mem1, and then we're going to jump back to get cube. Otherwise, what we'll do is we'll do a step up, and if we're standing on a data cube, or rather if my item is greater than what we're standing on, then we will... I wonder if I can just pick up the item on the ground while I'm holding one and just swap items. I didn't actually try that. Let's give that a shot and see if it works. So what we'll do is we'll just keep doing that. And this should eventually get everybody to shred the smallest items in their list in order. Okay, yeah, if they're already holding something, then they don't do the swap. Okay, that's annoying. That's really, really annoying. I wonder... what I can do is... I can just go into another loop where I keep stepping down until I find an empty tile, drop the item, then go back up and pick up the smallest item. The other thing that I can do, actually, that's kind of clever, is I can just sort everything to begin with, and then have a loop where I just go through and pick up items until I shred them all. That would be really, really classy. That's actually a really classy solution. I like that a lot. But swapping stuff is only really easy if you have other workers to do it with you, because then they can actually swap positions physically. But we don't have that, unfortunately, so what we'll do is... sorry about that. We'll set my position as mem1. Huh. I don't know what this is about. Because I'm setting this... Okay. I can't tell if this is going to set that as a tile, or if it's going to set it as the value on the tile. I'm sure that it's going to set it as the value on the tile. Huh. What about nearest... I It'd be cool if I could just do the, nearest empty tile. But I can't quite do that. And I can't just have people, like, do what they did beforehand, which is step to the left, drop the cube, and then step to the right, and then, this is confusing and hard. And then there's this row, which has more cubes than I have spaces to drop the cubes. So I can't just drop all my cubes in a line. What I am thinking could be kind of funny is if I just seek out every single cube in its smallest, like... No, I can't do that either. Like, just find every cube that's small, or the smallest globally. But that's not gonna work. If you set a tile with a cube, it saves the tile and the number. You can compare it with ifs and also step towards it. Awesome. So I will set that as that tile. Okay, that's all I needed to know. Thank you for giving me that little tip there. So what we'll do is, if my item is greater than that spot, then what we'll do is we'll just step around randomly until we find an empty tile, put it down. But that's crazy. But it's also going to work. So what we'll do is, my item is greater than that, then we're going to enter another loop. So we'll pick it up and we'll just step either up or down. And if I'm standing on a nothing, then we'll drop it and we'll break out of this loop. Or no, we'll drop it. Oh, God, this is insanity. No, this will work. So we'll drop what we're holding. We will then step back to Mem 2. And then we'll jump back to this step. This is weird, but I like it quite a lot. Otherwise, we didn't find a nothing, so we just take another step in a random direction, and check if we're standing on a nothing. Alrighty, this is hilarious to me. This is gonna get real magical real quick when we have to do our first comparison. So they're already holding us something. So then they step, they drop that. Okay. The other thing that they need to do is after they do their step to Mem 1, or Mem 2, then they pick up the cube. I had that in a slightly wrong order. So they pick up 2. 34. This is working. I'm looking at this person. They're currently stepping around randomly until they find an empty spot with which to put their tile down on. They found it, then they're going to walk back to 6 and pick up 6. They're going to walk all the way down with 2 and shred that. 28 is smaller than all of these numbers, so this worked with random stepping around. Hey, I solved it, didn't I? And watch, they're going to pick up 17, shred that, 36, shred that, 37, shred that. Hey, that's actually not terrible, I don't think, in terms of the speed challenge. It's bad for size, but I kind of nailed the solution. Kind of. And we'll do Seek and Destroy 3, and hopefully I won't delete my solution between the recordings next time. So thanks for watching.